Welcome back to our Storm Chat, where we dive into major weather events. Today we're talking about a truly intense case, Hurricane Helene. This report is a behemoth of data, covering everything from Genesis with a Central American gyre to its devastating inland flooding. It's like reading a meteorological epic, right?
Absolutely. It's fascinating and a bit overwhelming. From formation on 20th September to its landfall near Perry, Florida, the report shows Helene ramped up from a tropical disturbance into a full-blown Category 4 hurricane, with peak winds hitting 120 knots and central pressures dropping to 939 more. That rapid intensification is really something, especially when you look at how it affected hundreds of thousands.
And, the report goes deep into observational details, aircraft recon flights, drops on data, surface wind observations, and even satellite imagery. It demonstrates that Helene's wind field was enormous, with tropical storm force winds extending over 360 nautical miles in its northeastern quadrant, which is why the storm surge was catastrophic, with inundation levels up to 16 feet in some areas.
Right, the coastal warnings were intense too. The document details everything from tropical storm to hurricane watches and warnings. They issued a hurricane warning for the Florida Big Bend region well ahead of landfall, which certainly saved lives even if the damage was enormous. The coordination between emergency managers and the National Hurricane Center was remarkable.
Now, something that really caught my eye was the extensive track and intensity forecast evaluation. They compared the official forecast with model guidance, GFS, ECMWF, even Florida State Superensemble, and noted that while some models outperformed the official forecast at 36 to 60 hours, overall the NHC did a stellar job given the complexity.
I do wonder, though,
if the reported error metrics truly capture the challenge posed by Helene's rapid changes.
That's a good point. The official intensity forecast errors were, as noted, lower than many of the intensity models for some time ranges, but the overall large error in forecast track for longer terms shows how challenging it was. It felt like forecasting Helene was more about risk management than pinpoint accuracy, even with state-of-the-art models, especially given the huge public safety implications.
And then there's the rainfall analysis. Some areas in the Appalachians saw upwards of 30 inches of rain, triggering flash flood emergencies even up to 34 times in some counties. The cascading impacts, including landslides and river flooding, underscored how multi-hazardous these events can be, which makes this report so critical for future mitigation strategies.
It really does. The meticulous breakdown from wind gusts measured across states to storm surge levels over coastal communities provides an invaluable record. And, despite my admiration for the technical detail, I slightly challenge the view that all forecasts were near perfect. Given Helene's unpredictability, there's room to ask if our models need to get even better. That's exactly what this level of scrutiny is meant to fuel: ongoing improvement.
And let's not forget the aftermath. With estimated damages approaching $78.7 billion and power outages affecting millions, it stands as the seventh costliest hurricane in U.S. history. This report doesn't just provide numbers, it tells the story of preparation, warning, and response on an unprecedented scale.
Yeah.
It's a stark reminder of why understanding these events in such depth is vital.
In short, Hurricane Helene is more than just a weather report. It's a case study in meteorological extremes and emergency management. And while the data is overwhelming, it helps us learn and prepare better next time. Thanks for breaking this down with me.